Jai Hind to all. Myself Nupur Mittal. Today I am going to discuss about the time response analysis of control system. So these are the basic content of today's lecture. Here I will first tell you about the response of the first order system, right? We will discuss one by one what is first order system, what is second order system, and then we'll talk about the different inputs which are subjected to a particular control system. What will be the effect, what will be the steady state error of a particular system, particular control system when it is subjected to a step input, when it is subjected to a ramp input, and when it is subjected to a impulse input. So before talking about the time response of the control system, we should know what is first order system, what is second order system, how we'll define the different order of the system. So the order of any system can be defined by the, let's say this CS upon RS is will be known as the transfer function of any system. So when there is, see, I have taken this example, s raised to the power k, CS upon RS will be equal to k upon s raised to the power 1 plus 2. So the order of the system can be defined as the power of S in the denominator of any transfer function of a particular system. Here you can see that the power of S is 1. So this is known as the first order system. If we define, let's say if, since we know the transfer function will be CS upon RS, that is Laplace transformation of output to the Laplace transformation of the input is the transfer function. And if it is having, let's say this is the s raised to the power 2, 2s plus 3. This is the value of the transfer function. So this is the second order system. Why? Because here the highest power of s in the denominator of the transfer function is 2. So it is called as the second order system. And similarly, this will be the first order system. Similarly, we can define as third order system like this. So you can say this is the third order system since the highest power of s in the denominator of a transfer function is 3. So like this, in this we can define the order of any particular system. Now what we have to find out here? We have to find out the time response of a control system. Time response means the output of the system, right? Here for this system you can see this RS is the input of the system and this CS is the output of the system, and input can also be called as the excitation, right? Similarly, output can also be called as the response of the system. Now time response means the response of the system in time domain. Here CS is in frequency domain. So we have to find out the CT for first order system. Okay, so let me clear this first so that I have taken this block diagram for the first order system. You can see here we have, this is the response. So for this block diagram, first we will find out the transfer function and then correspondingly response of the system. Okay, then we'll analyze this system. Okay, so here you can see this is known as the GS, that is forward path transfer forward path gain, and here you can see this is a closed loop control system with negative feedback, that is unity feedback. Here HS is equals to 1 for this system, right? So the transfer function of such system can be defined as GS upon 1 plus GS HS, right? When we put the value of GS HS here, we will get the transfer function of this system. So here CS upon RS will be equal to 1 upon ST plus 1 upon ST into 1. So after solving this, we'll get the value of Cs upon Rs will be equals to, St will come out to be cancel 1 plus St. So here you can see the highest power of S in the denominator of the transfer function is 1. So this is called as the transfer function of first order system, right? So the response of first order system will be Cs will be equals to Rs into 1 upon 1 plus St. Now, we will find out the response of the system for different inputs, right? We will put the value of this Rs as unit step input, unit ramp input, unit impulse input. So now let's discuss this in detail. When we have applied the unit step input for the system, that is Rs will, you can say Rt will be equal to Ut and the Laplace of Ut is 1 by S. So from previous equation where Cs is equals to Rs into 1 upon 1 plus St, we will put the value of Rs here, right? So it come out to be 1 upon S into 1 upon 1 plus St. This is 1, right? So by taking partial fraction of this, we will get Cs is equals to 1 upon S minus 1 upon S minus T upon St plus 1, right? So we can further simplify it as 1 upon S minus, we'll take common, T common from this denominator. So it will be S plus 1 upon T, right? And we can cancel out this T. So when we take inverse Laplace transfer of Cs, we'll get Ct. So by using partial fraction, we are getting this. Okay, and by taking inverse, inverse Laplace transformation of the above equation, we will get Ct is equals to, the inverse Laplace transform of 1 by S is actually Ut, right? That is step function, and you can write it as 1 also, either Ut or 1, minus 1 upon S plus 1 by T. So the inverse Laplace transform of this will be e raised to the power minus T by capital T. Okay, so this is minus T by capital T, right? So here Ct is response of the time response of this first order system when subjected to unit step input. We will get Ct is equals to 1 minus e raised to power minus T by capital T. Now here we have Rt is equals to 1, right? That is Ut for unit step input. So we can calculate the error. Error will be, you can see here, this is Es in this diagram, which is Cs minus Rs will be Es. So here Et can be written as, that is Rt minus Ct, right? So Et will come out to be, Et will be equals to 1, here Rt is 1 and Ct is 1 minus e raised to the power minus T by capital T. So it comes out to be error. So error is coming out to be this, e raised to minus e raised to power. Now steady state error can be calculated as, steady state can be written as T limit T tends to infinity Et. So steady state error for this system is coming out to be e raised to the power minus e by t by capital T. And this is the graph for this system when subjected to unit step input. Here you can see one is the UT is the step, unit step input is applied here, and you can see here we are getting the difference between the two is 0.02, okay, at 4t, right, and it is approximately 0.638, okay, and this is the graph and this is the difference 0.98. So the error, you can see it is exponential in nature, and it will goes to difference between the input and output will become 0 once it becomes unity, right? As the time increases, this graph will become unity near to the in the steady state. So we will get the difference between the input and output as 0. Now coming to the ramp response of the system. So same system I have taken here. So here again we can write value of Cs upon Rs will come out to be 1 upon 1 plus St, right? Now value of Rs we will take here as T into Ut for ramp input, right? And for unit step ramp, Rs will be equal to 1 by S square. Now we can put this value in this equation so that we will get the value of Cs is equals to 1 upon S square into 1 upon 1 plus St. Now when we take partial fraction of this equation, right, taking partial fraction of the above equation, we will get the value this Cs is equals to 1 upon S square minus T upon S plus T upon S plus 1. Now we can take inverse Laplace transform of the above equation. We will get the time response of the system when subjected to unit ramp input. So taking partial fraction of above equation, will get Ct will be equal to 1 by S square, the partial fraction of, taking inverse Laplace transform of above equation, we get 1 by S square. The inverse Laplace transform of 1 by S square is small t, and the Laplace transform, inverse Laplace transform of 1 by S is step function. You can write it at ut or unit step function. For unit step function, you can write the value as simply 1. So t is a constant here, and we can write it as into 1 plus capital T into e raised to the power minus t by capital T. So this will be the response of the first order system when subjected to unit ramp input. Now simply again here we can calculate the value of the error. First we will calculate error, that error which is here, that is difference of Rs minus Cs, Rs and Cs, right? And then we can calculate the steady state error. Depending upon that, we can calculate, we can draw the graph. So error will be here Rt minus Ct from this graph. So it comes out to be here Rt, we have Rt is equals to T for unit step, for unit ramp input we have Rt is equals to T, right, and minus the value of Ct, which is T minus T into plus T into e raised to the power minus k T by capital T. So it get cancelled and we'll get error as capital T minus T 1 plus, we can write it as ES for this system will be capital T minus t into e raised to the power minus t by t. Okay. Now we can calculate the value of steady state error. Okay. So steady state error will be ESS is equals to limit t tends to infinity, right? And it comes out to be into ES, which is here limit t tends to infinity, capital T 1 minus e raised to the power minus t by capital T tha. Now put the value of small t is equals to infinity, e raised to the power 0 is 1. So it is coming out to be capital T. Here steady state error is capital T. Right. So you can see the graph we have observed from the first order system when subjected to unit ramp input will be this. Here this dotted line shows the input and this is the output. You can see that the input velocity matches with the output velocity, but the output velocity lags behind the input by capital T, right? It will lag behind the output by capital T. Okay. Now, this is the impulse. Now coming to the impulse response of the first order system. So the impulse response of the first order system is we have the response. First of all, let me write down the transfer function of the first order system that we have discussed in the previous slide also. So it is 1 upon 1 plus ST, right? Now, so CS we will getting the CS will be RS into 1 upon 1 plus ST. Now, the impulse response of the first order system will be, impulse response will be RS is equals to delta, RT is equals to delta T, and we can write it, its Laplace will be RS will be equals to 1. So putting the value of this RS in this equation, we will get CS is equals to 1 into 1 upon 1 plus ST. So by simplifying it, simply we can take T as common here, 1 upon T into, it comes out to be 1 upon S plus 1 by T. Okay. By taking inverse Laplace transform of this, we will get CT here is equals to 1 by T into e raised to the power minus T by capital T. So this will be the response of the first order system when subjected to unit impulse response. Unit impulse input, right? So CT is this, and similarly we can calculate the error, which is, so error for this system will be, error will be ET will be equals to RT minus CT. So here RT is 1 minus, this will be the error 1 by T e raised to the power minus T by capital T. Okay. Now steady state error will be limit T tends to infinity ET. Okay, let me define ET as capital so that there will be no confusion. Okay, this will be the error. Okay, so when we put the value of T infinity here, it is from minus infinity is 0 and it is coming out to be 1 by T. Okay, see, yeah, it is coming out to be 1 by T. So you can see here, it is coming out to be 1. Since e raised to the power minus infinity is 0, so it is coming out to be 1. So you can see here that this graph represents the exponential decay of the response of the system for positive value of T, and it will be 0 for negative value of T. So that's all for today. In the next lecture, I'll talk about the response of the second order system when subjected to different inputs and what are the specification of the second order systems, right? How to define them and how to solve the numerical on these problems. That we'll discuss in the next lecture. Thank you.